Hey there, this is the last part of chapter 4 practice exam. This includes the counting portions. That's problems 16 through 23. And so I'm going to assume that you have this document already, and I'm going to flip the camera and walk us through it. This is mostly just calculator work. It's not particularly complicated. So we're going to start with number 16. We have 11 factorial over 7 factorial. And if you remember, 11 factorial can break down to 11 times 10 times 9 times 8 times 7 times 6 times 5 times, but that 7 times 6, that is 7 factorial. And the idea is we can break it down like this so that we can reduce out the 7 factorials. And we're left with 11 times 10 times 9 times 8. 11 times 10 times 9 times 8. 7,920. And we have no unit with this one, so we don't really know where else to go with that. Number 17 says, how many ways can 6 people be chosen and arranged in a straight line if there are 8 people to choose from? Well, arranging people and wanting to know how they are arranged in a straight line, that means that the order matters in that case. So we're going to use a permutation, not a combination. So there's 8 people to choose from, permutation 6. And the way we find that in the calculator is I type in 8, I hit math, I go to probability, and I go down in PR, and then 6. Arrangements. Next up, number 18. In a certain lottery, 5 different numbers between 1 and 20, inclusive, are drawn. The word inclusive there means that we are including 1 or 20 is a possibility. These are the winning numbers. To win the lottery, a person must select the correct 5 numbers in the same order, that's key, in which they were drawn. What's the probability of winning? Now, this one, they want a probability, not just a number. Now, because the order matters in this case, there are 20 to choose from. That's going to be a permutation, since the order matters. So once again, so we have 1860480. That's 1,860,480. Now they want a probability, and the probability of winning, well, that is 1 out of 1,860,480. All right, and so I'm just going to leave this here as my final answer. The reason is because we're going to get a number that's so tiny. In fact, I can just hit the reciprocal button here. And that means I have to move that decimal 7 places to the left. So that means it's going to be 6 zeros and then the 5. So I'm just going to leave it as a fraction like this. Number 19. A class has 8 students who are to be arranged seating by lot. What is the probability that the students will be arranged in order from shortest to tallest? And we're assuming that none of them are the same height. Well, I'm going to need 8 factorial for this. The reason being is we're using all 8 spots. We're not chopping it off like we did with some of the previous ones, or out of 15 we only need 7 or something like that. This one we need all 8 slots. So it's just 8 factorial, which is 40,320. And so the probability of small to tall is 1 over 40,320. And this one, the denominator is small enough, I'm going to actually divide that out. So I'm going to find the reciprocal there. And I'm going to write it out like you see it. This is an approximation, 2.48 times 10 to the negative 5th power. I would accept that as an answer. That would be a correct answer. You could also actually move the decimal. So 0.1234248. So either of these would be acceptable answers. Push that up a little. Number 20. A tourist in France wants to visit 6 different cities. How many different routes are possible? Again, since we're using all 6 digits, this is just flat out 6 factorial. And this one, they don't want a probability, they actually want the number of routes. So 6 math probability factorial, 720. All right. The organizer of a television show must select 5 people to participate in the show. The participants will be selected from a list of 30 people who have written into the show. If the participants are selected randomly, what is the probability that the 5 youngest people will be selected? So here we're looking for a probability again. And so we, because the order doesn't matter, as far as the number of people that are there, that's going to be 30, choose 5. Meaning of the 30 people, there's only one way that it's going to be the 5 young people, so the numerator. So 30. We're now using C for combination or choose. You'll hear teachers say. Ooh. So that comes to be 142506. And actually the probability of the 5 that we pick, it's going to be the 5 youngest. It's going to be 1 over 142,506. Again, you could divide that out if you wanted to. I'm not going to. Again, once we get, even this one is a little much. The number 19 seemed a little much. I do want to warn you on number 19, if you do divide it out, if you put 2.48, that is very wrong. That is not a correct answer. So make sure that you either do times 10 to the negative 5th or you write it out with the proper decimal. If you just put that, that's not correct at all. All right, so that was 21, 22. There are 5 members on a board of directors. They must select a chairperson, a secretary, and a treasurer. How many different slates of candidates are possible? In this case, the order does matter because we actually have titles connected with them. So there are 6 permutation in this case because the order matters. And then there's 3 officers. So 6 math probability. This is now permutation 3. So this is going to give me 120 slates. Their wording. There are 8 members on a board of directors. they must form a subcommittee of 6 members. How many different subcommittees are possible? In this case, the order does not matter. So that's going to be a combination. 8 choose 6 or 8 combination 6. 8 combination 6. 28. 28 subcommittees. Possible subcommittees. All right, thank you very much.